Also, big thanks to the organizers for putting on. Huh? Is that better? Okay. Sorry? Okay. So thanks for that introduction, and thanks to the organizer for putting on this great conference. As was introduced, I'm Mathias. I work for Overleaf as a software engineer. I primarily do my work on the editor page of the product. So that means the phase where users are actually writing their documents and before we pass it on to the LaTeX compiler. So basically the context of this talk is that we're doing the work in a JavaScript context, in a browser context, rather than in the context of the actual LaTeX compiler. So a bit about why we want to parse the LaTeX in the browser rather than just handing it off. The idea is that Overleaf provides two modes of editing. We have a code editor and we have a visual editor. The code editor is a source editor like you'd expect. You have your LaTeX source code and you have syntax highlighting, but not much else in terms of the text that you're interacting with. Then we have the visual editor, which offers a rich text editing experience. So we take some of the LaTeX elements and enrich them. So instead of showing text BF and an argument, we just show that the argument is being bold. And in both of these scenarios, we want to provide contextual help during editing. So things that we can extract from the document are things that we can help with during the writing process. So example of that could be contextual autocompletion. When you're writing begin, we might want to autocomplete environment names, or if you're writing backslash, we know that we want to write a command, so we might want to suggest commands that you've used previously in your document, or ones that you've just defined. So to do those kind of features, we need some type of integration with the user document. The other side of this, which is more prevalent in the visual editor, is that we want to simplify some of the more either difficult or tedious tasks. So something that new users might find difficult is things like figures, things like tables, where they don't yet know all of the syntax, so it can be quite intimidating getting started with. So we have tools to make that process easier, where you can just press buttons, interact with visual elements, rather than having to write the LaTeX code. In terms of the tedious task, just to provide an example of where it's not necessarily just for new users, if you, like me, have written a table in a LaTeX document, you've written a large table, many columns, many rows, and you realize that you forgot to add a column. To go and add that column in, first modify the column declaration, then you go through each row, count the right number of ampersands, add your ampersand, and then once you're through all rows, you have your new table and you can add the content. With the tools in the visual editor and with an understanding of the LaTeX source code, we can provide tools that make that easier, and you can just add a column with the press of a button. So where do we do these integrations? Well, these are all examples of things we do in the source editor, things like syntax highlighting. I'm not saying that you need a full parser to do syntax highlighting, but if you already have the parser, it certainly doesn't hurt. Autocompletion, as I mentioned, we can make that contextual based on what you're currently editing. And finally, the file outline, where we extract sectioning commands from the document and provide them in a list so you can easily jump to the right place. On the bit more involved side, in the visual editor, we have things like visual decorations, where we use our understanding of the source document to extract the math mode and use Mathias to typeset that. As I said, show bold text as bold. Things like sort of decorations, where we replace elements of, or replace sections of the source document with these visual representations. The figure modal, as I discussed, rather than going and editing your LaTeX source code, you can press around on the buttons, change the settings that you want. And finally, the table generator, where you can do these structural modifications. You can change the border theme, you can change column structures, rows, and so on and so forth. So we have the why, and we have the where, and then finally the what. What is it that we need in order to do these things? Well, we need a structural understanding of the source document. So if we have a document here on the left, a document class article, we have a document environment and some math inside. What we're essentially looking for is some type of tree representation of that document. So first things first is the command that's comprised of the actual document class control sequence as well as the argument of article, and then an environment with a type document and the content inside, which is the math, which itself is comprised of the 2+5 text. This representation here is not really one that's mirrored in the TeX interpretation, so I'm just going to spend a few minutes talking about how tokenization happens in TeX and how that differs from the sort of tree structure that I've discussed here. So essentially what TeX does is that you have your input, and that'll be consumed character by characters and turned into tokens. So, and that is all done based on character codes. So the first thing that the TeX interpreter will do is to read the T, look up that's a character code 11, a letter, pass that to the interpreter, continue down the line of letters, find a space, that's category code 10, and continue until you find a category code 0, which is an escape character, we're most commonly represented by the backslash. That doesn't get passed to the interpreter, but it instead signifies that the following text should be treated like a control sequence. And if you typeset this, you get what we all expect, text in, and then the output of the control sequence text. This doesn't give any big difficulties in terms of what I showed, but the thing is that these rules, these category codes, are just one of the things in the TeX interpreter that is dynamic. We can change the rules on the fly. We can change the rules of tokenization on the fly. So in this example, what we have is an exclamation point, and then the cat code command. This essentially changes the category code of the exclamation point to being 0, followed by exclamation point tag. Now during the tokenization phase of this, first time we see the exclamation point get category code 12, which is essentially saying it's not a letter, it's not a space, it's not very interesting. And then we have all of the tokenization of the command itself. And remember that we're doing this token by token, so eventually this will all have run through the interpreter, meaning that we've updated the category code of the exclamation point character. So when we see the exclamation point, it is now getting assigned as an escape character, and the next thing is interpreted as a control sequence. So the output here, exclamation point, and then the output of the control sequence. And this is an issue because if we want to set up static tokenization rules, that doesn't really work in terms of supporting the entirety of TeX and all of the dynamic rules. Luckily, we don't really need to. We are in the process of writing user documents. They don't tend to change category codes too much. They don't tend to create control sequences that would redefine themselves. Like those kind of behaviors is not really something that we see in user documents. So for the most part, we can ignore them. So we can set up tokenization rules based on the standards of LaTeX. So a control sequence should always be a backslash followed by some letters. Furthermore, and people might disagree with this, but there is a great number of standard packages and structures that are commonly reused. So if we ascribe some definition to some control sequence, well, that would probably apply to most use cases of it. So in general, we can agree that we can't, with these static rules, parse all of TeX, but we can probably get close to parsing most user documents. So the way that we actually do this in practice is that we're using a parser generator. It's called Laser, and it's developed in tandem with CodeMirror 6, which is the editor we use on the page. It's a parser generator developed specifically for code editors, so it handles all of the intricacies that comes with that, which is things like built-in error handling and recovery. User documents are quite often in an in-between state as you're typing your document. So this Laser, the parser generated by Laser handle that gracefully. So we build at Overleaf and maintain a LaTeX grammar written for the Laser parser generator. And the way that it functions is that we understand the core construct of the LaTeX language, and then we add special cases whenever we need to understand more about a certain construct. So if we need to understand the text BF control sequence in particular for the visual editor, we can add a special case for that. I want to go through a little example of building such a grammar. And the reason is that it would take entirely too long to present the full grammar, so I'm just going to build one up from the ground instead and show the concepts that we're using instead. So we have a small LaTeX document, we have document class article, document environment, some text, and some nested environment that could do some fancy formatting. To create a grammar, to create a parser for this document, well, we can first look at which tokens we assume would appear. In this case, control sequences, which, as I said, is now assumed to always be a backslash followed by letters. We have open and closing braces to delimit arguments. And we have a word, which is just letters and some white space as well. And then to define the structure of the document, from the tokens, we see that we have some entry point, which basically describes our entire document. A document contains content, and content can either be commands, text, or spaces, or any combination of those. A command is a control sequence followed by arguments, and arguments are content enclosed by opening and closing braces. And finally, text is just, in our case here, word. This grammar run through the laser system generates a parser, which can actually parse the previous document, so this document here, into this tree structure. And now we're getting closer to that syntax tree that we were looking for. But it has one issue here, is that it's a very flat structure. This here would represent the document class article. This here would represent the begin document. Then we had some text. Then we had a begin fancy text. Some text inside that environment, and then two end commands. But this doesn't really show a structural understanding. It just shows that we've found all of the commands in the document. So say that we want to understand the nested structure of environments. This is an example of such a special case that I mentioned we could add support for earlier. So say we want to support environments, so now content can be commands, text, environments, or spaces. And what's an environment? Well, that's a special control sequence, begin, followed by the name of that environment, has some content inside, and has an end control sequence. And it's quite clear here that there is a recursive definition. So environments contain contents, which can be environments, which contains content. But this is all handled by the parser and allows us to get these nested structures here, the tree representation that we're looking for. So now the content of the document was the document class article, the begin document, and the content of the document environment was some text and another environment inside it. So now this is one example of adding some special behaviors to control sequences, but it really does expand to pretty much anything that we want to add support for. And that is the way that we're doing things in practice as well. So if looking at, this is the output of the real parser running on Overleaf. So if we have a begin tabular with some column specification and some content, what will be generated is, or at least some of what will be generated is this content here. And we can see the same things from the previous outputs represented in the actual parser here. So we have environments with arguments with open braces and closing braces, and the content is, well, this is our version of text, but it has white space and text and ampersands and all of that. So this structure is something that we can actually analyze and provide features based off of. There are some limitations, and there are specifically limitations, well, one about the static tokenization rules, but also limitations about which commands we know and which ones we don't. So we do understand the concept of an unknown command, something that we don't know how it works. But in this case here, the top one, we have a custom command. We haven't prescribed any meaning to it, followed by an opening brace, some content, and a closing brace. And of course, in running this through the interpreter, we would know if this was a macro that took 0 arguments or if it's a macro that takes 1 argument. But that's something we won't be able to tell statically without actually running the engine. So in this case, we have to make decisions, and we've decided that this would always be treated as an argument, for example. It doesn't really cause issues in practice. Same thing here with internal state in the interpreter. If I have a command typeset this could put you into math mode, and this should actually be typeset as math. But again, something that we won't be able to tell statically. We will never be able to guess what a command would do without adding specific support for it. Okay, so we have a grammar. We have the syntax tree. Now what do we do? What can we use the output for? Well, a few things just sort of fall into place with this output. If we assign a color to each node type, well, that pretty much gives us syntax highlighting. If you use the position data from your syntax tree, you can change your autocompletion source depending on what you're currently working on in the editor. So that could give you citation key search if you're inside a site, or it could give you environment names if you're inside a begin. Then if we start replacing nodes with custom elements, well, that would form the basis of the visual editor. So taking one of our nodes, text bf control sequence, hide that and take the argument and mark it bold, well, that sort of gives the intuition of how we would do elements in the visual editor. And finally, if you remove entire sections of the syntax tree and replace them with some tool, it could be a table generator, that forms the basis of the what you see is what you get editing features in Overleaf. And I want to spend a bit more time talking about WYSIWYG, because if you're like me, you could be a bit hesitant using such tools, and that's usually because you've had an experience like this. You have some handwritten code here on the left. That all looks good when loaded into the tool, and then you make a tiny little fix to this typo here, and your output suddenly looks like this on the right. I think what happened here actually was that while clicking after the S here, I hit one of these dashed lines, which automatically assigned the height to each table cell. And this is obviously not something that we want to do with users' LaTeX documents. We have a lot of respect for the LaTeX code that people write in Overleaf, so we have some guiding lights to how we want to treat WYSIWYG in our editor. The first one is that we want to perform minimal edits. One thing is we don't want to change your formatting and insert a lot of spurious content like in the previous example, but also we have things like track changes, and if you changed a typo in a table, we don't want it to look like you've deleted and created an entirely new table. Same thing, we want people to be able to coexist between the two editors, so if one is writing in the source code and one is writing in the visual editor, then we don't want one to mess up the code for the other. The second thing that we're going for is writing appropriate LaTeX. We don't want to be inserting a lot of LaTeX code just to make sure that it looks exactly like it does in the visual preview. That essentially leads to the situation from before, but it also leads to very fragile code that will probably break if they try to modify anything afterwards. And finally, if we don't understand it, we don't edit it. That means if there's some content that we don't understand, we would much rather just show the user the LaTeX code and trust them to edit it, rather than trying to force our understanding, our broken understanding, onto the code and then instead display it wrongly. So the equivalent example in Overleaf would be I have my LaTeX code written on the left, which shows the same table. I do my modification in the visual editor, and on the right it's essentially the same, but we've changed only the content in the associated cell. And this would apply even if you're changing more than just content. If you were changing, say, the border style away from book tabs, we would only be touching the bordering commands and the column specification. We wouldn't, again, try to mess around with white space or anything like that. And that applies if you're doing other structural changes like column modifications or deleting a row and so on and so forth. So in summary, we're using a laser-based parser for conventional LaTeX. We understand that we're not capturing all of TeX and all of the dynamic aspects, but in reality, we don't really need to for most user documents. We support common structures like commands, environment, modes, etc., and then we add special cases when we need to understand something better, and we have added quite a few of those already. And that is what drives many of the editor features like syntax highlighting, autocompletion, and the more involved WYSIWYG editing tools that we provide. That brings me to the end of my talk, so if you have any questions, feel free to ask.
Any questions for Mathias?
Determining the syntax tree sounds time-consuming. How often do you reconstruct it?
Yes, good question. This is one of the benefits of using the laser parser generator as well, because it's made for source editors. It supports incremental parsing. So it means that we reprocess the tree on every keystroke, but we're doing very small updates to it, so we don't need to repass the entire document on every key press.
Sounds good. Thank you.
Did you specify precisely the data structure used by your parser? In other words, if I would like to use it with my own programs, can I do it?
I'm not sure I'm not sure I understood completely, but it generates an LR grammar in JavaScript. So is that what you, or do you mean the grammar itself?
Basically, a parser returns.
Oh yeah. Oh, so you're talking about can you apply the other things to the syntax tree, or like can you move the syntax tree out of the parsing in Overleaf? Like can you use the parser and get a JSON structure? Is that what you're asking? It has some utility function. I'm sure you could generate it easily, but it is generating classes within its own, from its own library. But yeah, I'm sure you could generate whatever format you wanted from that. It has built-in structures for like walking the tree and stuff like that.
You said that you aim to do it with minimal number of edits. So, how does it? You said that you intend to do it with the minimal number of edits. So, how does it compare, like with this editor and without it?
Well, ideally, it would look like if you were doing the edits by hand. And that is certainly what we're striving for. So basically, if we're looking at the table generator example, this one, the syntax tree will contain the position of each of the nodes that we're interested in. So if we, for example, are changing the border theme, we want to make the table fully bordered instead, for example. We would only modify the column specification as well as the existing border rules, and only insert at positions after the row breaks. So I mean, the goal is that it shouldn't change too much.
So no, I meant not how you do it, but actual data. What have you tried with it and without it and seen the difference?
Do you mean ask someone to do it by hand and ask someone to do it in the tool?
Yeah, with the tool and without the tool.
Yeah.
What is the difference in terms of numbers, actual numbers, not the theory part of it?
I can't give you those numbers. We haven't done that kind of test, but I can't see how you would. Like, I would assume that human would probably have slightly larger changes if they wanted the formatting.
No, not a human, with some other editor versus this editor. Comparison
okay.
between.
Right, so comparing it to other WYSIWYG tools. I don't have those numbers, sorry.
Will you also be supporting in some manner like TeX diagrams, for example, unified modeling language stuff?
We could. We certainly could. There is the laser parser generator supports embedded languages. So if the need was big, we could add support for, within this environment you should parse it as UML, or within this environment you should parse it as TeX. But it's not something that we're doing at the moment.
Okay.
Question for myself. The syntax tree generation happens in the backend, or in the front end JavaScript, I assume in the browser client.
It happens in the front end.
What's the performance impact, particularly if you have a large document?
I can look up some exact numbers if you're interested afterwards, but
does it have a noticeable performance impact?
In general use, no. You might be able to construct examples where it would. If you're holding down a character, you might get some problem if you've constructed a weird document. But in general, tested with AMS math documentation, like fairly big documents with no problem.
Okay, thank you.
So, thanks for the talk. I was just curious about this principle of minimal changes done to the content and formatting. I was curious, how far do you go in ensuring that it looks consistent? I mean, it's clear that if you just want to edit a single cell, that you just touch this part of the text and keep the rest the same. But if you just edit a row to the table on the next page, would you try to keep the indent the same, or how far do you go with this?
Yeah, so the example of adding a row to this would essentially look up the end of the previous row and only insert the line break. I think we would try and guess the correct indentation for the new row, but we certainly wouldn't touch any other row while doing it. So I think we would generate a line with probably indentation up to here, and then just space, ampersand, space, ampersand. So yeah, should be minimal.
Okay, thanks.
If no further questions, thank you, Mathias.